Hi everyone, in this video we're going to go over another Leetcode question. Remove nth node from end of list. Major tech companies like Amazon, Facebook, Microsoft, LinkedIn are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Given a linked list, remove the nth node from the end of list and return its head. Example, given linked list 1, 2, 3, 4, 5, and we need to find nth node from the end, in this case 2, and the nth node from the end is 4. We need to remove this node and return the new list. After removing the second node from the end, the linked list becomes 1, 2, 3, 5. Note, given n will always be valid. Follow up, could you do this in one pass? So we are given a linked list and we need to find the nth node from the end, and we need to do this in one pass. This part is important because for linked lists we don't know the length of the linked lists. So for example, we can do one pass to find the length of the list. Then we can, in the second pass, we can go up to the link minus n position, and we can solve that way. But the question is asking us to do in only one pass. So let's get on the whiteboard and try to solve this question. So this is our linked list, and in the linked list questions, always try to remember three things. First thing is we create dummy nodes. These dummy nodes is before the head of the linked list and pointing to the head. This way, when we finish the question, when we want to go back and at any point, we can, if we want to find the head at any point, we can say dummy.next. That will always point us to the head of the linked list. So we create a dummy node. Just keep that in mind. And in most of the linked list questions, we use two-pointer approach. Sometimes these are called tortoise and hare approach as well. Hare walks faster, tortoise goes slower. For example, if you want to find the middle number in the linked list, that's also how you do it. We have a video about it. And in this one, we create slow and fast pointers. And the difference between slow and fast pointers will be 2. So we will start making fast pointer walk. 1, 2. When the difference between fast and slow is 2, n is 2, because it is n basically, we start making slow and fast walk together. So let's do it this way. So slow and fast will start walking together. So slow and fast is now at 3 and 1, 4 and 2. When fast at next is null, we stop. That means we find the final node here, the tail node. So what we need to do is we need to remove the nth node here. That means slow.next is the node that we are looking for. Because when fast reaches here, slow will be here, and this is what we were going to reach. So what we are going to do is we will link this node to this one. So this way we will remove the 4, and finally we will return dummy.next and return the new linked list that way. I hope this makes sense. So we keep the distance as the given number and start making 2 pointers walk. When fast reaches the end, we simply say slow that next, slow that next, that next. That's how we remove a node from a linked list. So all we do is slow that next, slow that next, that next. So this pointer, then this node will be gone. And we will return 1, 2, 3, and 5 as a new linked list. Let's check this in the code. We have the dummy node, linked list node. I put it 100 I did it in purpose. So I mean, the idea is you can put any value. It doesn't matter. Sorry. You excuse me. You can put any value here. It could be 1, it could be 100, doesn't matter. The idea is the dummy that next should be pointing to the head node. So dummy that next is head. We set the fast and slow pointers at dummy as well. So this is where we set our slow started in the beginning. And we start with the while loop. We start making fast pointer moving step by step. As long as fast at next is not null. So fast that next is null here, so we stop moving. Otherwise we are moving. And here we check, here we stop slow pointer. Slow will wait until n is less than or equal to 0. So every time we decrement n, so for 2, n is 1, n is 0, then start moving. That's the idea. Slow will wait until n is 0, and we keep the difference between slow and fast that way. Finally, when this while loop is done, this is going to be the picture. So when the while loop is done, fast will be here and slow will be here. The difference will be n. So we will simply remove slow that next, and remove the node that we need to remove. And finally we will return dummy that next. So we keep the reference to our head node this way. Let's see this in the code and try to understand. So dummy node, dummy that next is head, keeping the reference. Fast pointer, slow pointer, both of them are set to dummy. When fast at next is not equal to null, so start moving step by step. If n is less than or equal to 0, slow is slow that next. So as long as n is, so we are decrementing n, so every time fast moves 1 step, we will decrement n 1 step. When fast gets 2 steps, n will be decremented 2 steps. When it's equal to 0 or less than 0, we will start moving slow that next. When this while loop is ended, we will be at this point. Fast is here and slow is here. And finally, slow that next is slow that next that next. This is how we remove the node. And finally, we will return dummy that next as the head node. Let's submit this code and see if it's going to work. This one seems to work. So this is pretty much it for remove end node from end of the list question. This is a common question you may come across during interviews. So I hope it was helpful, and I have more videos coming up. If you subscribe to my channel, we can meet again in the near future. Thank you for watching. Goodbye.